Dear friends, before we dive into this explanation, I want to say that if you have any questions about this topic, feel free to drop them in the comments, and we'll be more than happy to help you with any answers you need. Okay, so now let me explain how a simple sine wave H-bridge inverter can be built using the IC IR2111, with a soft start and an automatic overload shutdown features. Referring to the IR2111 sine wave inverter circuit above, we have plus 600 VDC at top rail, written as plus 600 Vmax, and ground, 0V, at bottom. Here we connect the operation voltage of the inverter, which is usually a plus 310V bus DC. Then load is connected between middle points of the bridge. IR2111 driver ICs. Each IR2111 has two important outputs. HO, high side output. LO, low side output. HO is used to drive upper MOSFET in each half bridge. LO is used to drive lower MOSFET in each half bridge. We apply plus 12V to VCC pin of IR2111 for its internal power. Also BA159 diode is used to charge bootstrap capacitor, because high side MOSFET needs voltage higher than plus 600V to turn fully on. So BA159 plus 10 microfarads bootstrap capacitor charges when low side is on, then gives proper voltage to high side driver. You need to connect Arduino PWM pins as following. PWM number 1 from Arduino pin number 8 goes to IN pin of left IR2111, first half bridge. PWM number 2 from Arduino pin number 9 goes to IN pin of right IR2111, second half bridge. Arduino generates SPWM, sinusoidal pulse width modulation, signals in sequence. Since soft start is important, Arduino first gives small duty cycle, then gradually increases it step by step over time. That way no big inrush current happens suddenly. Now, how the MOSFET switching happens. Let us say Arduino sends high on PWM number 1 and low on PWM number 2. Then left IR2111 will turn on its HO and LO in sequence. That makes upper left and lower right MOSFET conduct. So current flows through load in one direction. When Arduino gives low on PWM number 1 and high on PWM number 2, then upper right and lower left MOSFET conduct. That makes current flow in opposite direction through load. So AC waveform is formed over time by alternating direction of current. Why bootstrap capacitor and BA159 diode is needed? We must know that high-side MOSFET gate needs voltage higher than VCC to fully turn on. So BA159 diode plus bootstrap capacitor stores charge when low side is on. Then supplies high voltage during high side on period. Without this, high side MOSFET would not switch properly. Soft start feature importance. When Arduino starts operation, we start with very small PWM duty cycle. Then step by step we increase duty cycle slowly. That way load does not get sudden power shock, and no big current surge occurs. Soft start protects the components and makes inverter start smoothly. If you want to add an overload shutdown feature, you can simply do it by modifying the circuit as shown in our next figure above. Here we see two BC547, one on each side of the circuit connected with the IN pins. Their bases are fed through 10K resistors from the RX sensing resistor. When the current is in safe region, then both BC547 remain off, and so the PWM signals enter the IN pins of both ICs without problem. But when the current rises above safe level, then the voltage across RX becomes high, and then it makes the BC547 conduct. As soon as the BC547 conduct, they short the IN pins to ground. When IN pin is pulled to ground, then the IC stops giving output, and so the MOSFETs turn off instantly. This stops the inverter and protects the MOSFETs and the load from further damage. So that concludes our explanation on the sine wave IR2111 H-bridge inverter circuit. If you thought this video was useful, please give it a thumbs up, share it, and subscribe for more electronics tutorials like this one. Thank you for watching.